So for question 6, page 45, part B. Part B says, estimate each file size except for the third one as millions of bytes or megabytes. So we're going to ignore the 1.1 megabyte and just try and estimate the first, second, and fourth numbers in megabytes. So the first, second, and fourth numbers. So if we look at the first one to start, it says 285 kilobytes. And when we place that in the place value column, it looked like this. Now if we're estimating in terms of megabytes, the megabytes column is here, so the decimal should go just to the right of the megabytes place value column. And if you look at this number, it's not even one whole megabyte. Since it's not even one whole megabyte, we do need to round to try and approximate how many megabytes it could be. So this number in megabyte form would be decimal 285, and then you can put 3 zeros, but they're just placeholders. You don't really need to put them. So if you round this to the nearest megabyte, we can look at, let's say we're going to round to the nearest tenth of a megabyte. Let's have a look at the next digit. Well, that's an 8. And since it's 5 or higher, what do we do to the digit in the tenths column? That's right, we go up by 1. So the 285,000 bytes rounded or estimated in terms of the number of megabytes is approximately 0.3 megabytes. Now if you were to show this estimated on a pie graph, it would be approximately 1/3, because 1/3 is approximately 0.33, and this is 0.3, which is really close to that. So we can show it in pictorial fashion too, as a picture. The next number is 15,000 bytes. Well, when you place 15,000 bytes onto the place value chart, you would have a 1 in the 10,000ths column, a 5 in the thousands column, or the kilobytes, and then 3 zeros. Well, that means there would be a 1 here and a 5 here and then 3 zeros. So if we were to round it or estimate it, it would look like this. Initially we'd have decimal 0.015 and then 3 zeros, which we don't have to write because they're just place value holders. Now again, if we're going to round here, we can round to the nearest hundredth of a megabyte because there's nothing in the tenths column. To round to the nearest tenth, as we did here, our answer is just going to be 0, essentially. So we need some type of a value that we can use to show the size of this file. So we should round to the nearest hundredth, so we need to examine the digit in the thousandths column. So this digit is 5 or greater, so the digit in the hundredths column should go up by 1. So 15,000 bytes rounded or estimated in terms of megabytes is decimal 0.02 megabytes. And the question for you is, how would you show that in a picture? Decimal 0.2. Is that equal to a quarter, or is it much smaller? Think about it, please. And the final one is 371,245 bytes. Well, as we did with this question, which was 285,000 bytes, we can write it down as decimal 371,245, and this would be megabytes. But because we have digits up here, we can easily estimate it and round it to the nearest tenth of a megabyte. So if we're going to round to the nearest tenth, have a look in the hundredths column. If it's 5 or higher, the tenth digit can go up by 1, and that's where we get 0.4 megabytes. And 0.4 is almost half, but not quite. So if you wanted to show it in a picture, if this represented a whole, 0.4 could be almost a half. So let's say that this was our half line. 0.4 could be maybe this much. just a rough estimate. It doesn't have to be precise, and you can show it as a picture too.